66 million years ago, Earth was struck by a cosmic catastrophe that changed everything. An asteroid, the size of Mount Everest, slammed into our planet with the force of billions of nuclear explosions, forever altering the course of life on Earth. This violent impact triggered the extinction of the dinosaurs, who had ruled the planet for over 160 million years. But here's the burning question that's haunted paleontologists for decades. Did the dinosaurs vanish in an instant? Or did some of these colossal creatures hold on for survival long after the cataclysmic event? The truth is far more shocking than you could ever imagine. Let's start by setting the stage for this prehistoric drama. The late Cretaceous period was a time of incredible biodiversity. Dinosaurs roamed every continent, from the towering Tyrannosaurus rex in North America to the horned Protoceratops in Asia. The skies were ruled by pterosaurs, while the oceans teemed with mosasaurs and plesiosaurs. It was a world that had been stable for millions of years, until it wasn't. To truly appreciate the magnitude of what was about to unfold, let's take a closer look at this prehistoric paradise. On land, dinosaurs had taken on an astounding array of forms. Herbivores like the duck-billed hadrosaurs and the armor-plated ankylosaurs grazed on lush vegetation. Carnivores, including the infamous T-Rex and the swift-footed dromaeosaurs, kept herbivore populations in check. The skies were dominated by pterosaurs, with wingspans reaching up to 10 meters in species like Quetzalcoatlus. These flying reptiles shared the air with early birds, descendants of small, feathered dinosaurs that had taken to the skies millions of years earlier. In the oceans, long-necked plesiosaurs and powerful mosasaurs reigned supreme. These marine reptiles had adapted to life in the water over millions of years, becoming formidable predators in their aquatic domains. Meanwhile, the plant world was undergoing its own revolution. Flowering plants, which had first appeared in the early Cretaceous, were diversifying rapidly. Broad-leaved forests were beginning to replace the conifer-dominated landscapes of earlier times. This vibrant, diverse world was about to be shattered by a force beyond imagination. A force from beyond this Earth, a harbinger of destruction, the Chicxulub impactor. This massive space rock, estimated to be between 10 to 15 kilometers in diameter, struck the Earth with a force that's hard to comprehend. The impact site, located on what's now the Yucatan Peninsula in Mexico, became ground zero for a series of catastrophic events that would reshape our planet's history. Now, you might be thinking, surely a single rock couldn't wipe out all the dinosaurs at once, right? And you'd be correct. The extinction of the dinosaurs wasn't as simple as asteroid hits, dinosaurs die. Instead, it was a complex chain of events that unfolded over time. But exactly how much time is still a matter of heated debate in the scientific community. Let's break down what we know happened in the immediate aftermath of the impact. The asteroid struck with a force equivalent to about 10 billion Hiroshima bombs, creating a crater over 150 kilometers wide. The energy released was so immense that it vaporized the asteroid itself and a significant portion of the surrounding rock. The impact sent shock waves rippling through the Earth's crust, triggering massive earthquakes estimated to have reached magnitude 11 or 12 on the Richter scale, far more powerful than any earthquake in recorded history. In coastal areas, these quakes would have generated enormous tsunamis, some potentially reaching heights of over 100 meters. The powerful shockwaves may have intensified volcanic activity around the globe, particularly in areas already prone to volcanism. The additional ash and gases from these eruptions would have contributed to the environmental crisis that followed. Billions of tons of debris were hurled into the atmosphere, some of it even reaching escape velocity and entering space. This material included pulverized rock, tiny glass beads formed from melted rock, known as tektites, and soot from widespread fires. The debris that didn't make it to space came raining back down, superheating the atmosphere to oven-like temperatures. This global heat pulse was so intense that it likely caused spontaneous wildfires across much of the planet. Imagine the entire world turning into a giant barbecue pit, far from ideal conditions for the dinosaurs. The impact also vaporized sulfur-rich rocks, releasing massive amounts of sulfur dioxide into the atmosphere. This, combined with nitrogen oxides produced by the extreme heat of the impact, led to the formation of acid rain. This corrosive precipitation would have further damaged plant life and acidified surface waters. So, did all the dinosaurs perish in this initial firestorm? Not quite. While many creatures, especially those in the Western Hemisphere, likely met their doom within hours or days of the impact, others may have survived this initial onslaught, but their troubles were far from over. The true devastation came in the form of what scientists call the impact winter. All that debris thrown into the atmosphere, it didn't just disappear. Instead, it formed a thick blanket around the Earth, blocking out the sun's rays. Global temperatures plummeted, possibly by as much as 20 degrees Celsius or 36 degrees Fahrenheit. Our once lush green planet was plunged into a dark, frigid wasteland. Now, imagine you're a dinosaur who somehow survived the initial impact, the earthquakes, the wildfires, and the rain of molten rock. You might think you're in the clear, but that's far from the truth. The impact winter brought with it a whole new set of challenges. With the sun blocked out, plants couldn't photosynthesize. The base of the food chain collapsed, setting off a domino effect that rippled up through the ecosystem. Large herbivores, which needed to consume vast quantities of plant matter to survive, were likely among the first to feel the effects. While the overall trend was cooling, the climate in the years following the impact was likely highly unstable. Brief periods of extreme warming may have punctuated the overall cooling trend, adding further stress to already struggling ecosystems. As carbon dioxide from the impact and subsequent fires dissolved in the oceans, it led to ocean acidification. This would have been particularly devastating for marine organisms with calcium carbonate shells or skeletons, including many species of plankton that form the base of marine food webs. The impact may have also released large amounts of toxic metals like mercury into the environment. These pollutants could have further stressed surviving organisms and contaminated food chains. This is where things get really interesting and where the scientific debate heats up. How long did this period of darkness last? How long did it take for the last non-avian dinosaur to draw its final breath? The answers to these questions are far from settled. Some researchers argue that the extinction was relatively quick, at least in geological terms. They suggest that within a few years, maybe a decade or two at most, the last of the non-avian dinosaurs had perished. In this scenario, the impact winter was short but devastating, wiping out most plant life and leaving herbivores to starve. Carnivores might have lasted a bit longer, feeding on the carcasses of their fallen brethren, but eventually, they too succumbed to the harsh conditions. But not everyone in the paleontological community agrees with this rapid extinction hypothesis. Some scientists argue for a more prolonged die-off, suggesting that it might have taken hundreds or even thousands of years for the last dinosaurs to disappear. One study, published in 2013, proposed that the extinction process took about 33,000 years. That's practically the blink of an eye in geological terms, but it's still a far cry from the dinosaurs died in a day narrative often portrayed in popular media. This theory suggests that while the initial impact and its immediate aftermath were catastrophic, some dinosaur populations might have persisted in pockets around the globe, slowly dwindling as they struggled to adapt to the changing world. The evidence for this more gradual extinction comes from several sources. The fossil record provides some clues, with dinosaur remains occasionally found in rock layers slightly above the iridium-rich clay layer associated with the asteroid impact. This suggests that at least some dinosaurs survived the immediate aftermath of the impact. Additionally, in the rock layers immediately following the impact, there's often a spike in fern spores. Ferns are typically the first plants to recolonize areas after a disaster. The presence of this fern spike suggests that, while the impact was devastating, life began to recover relatively quickly in some areas. Climate modeling has also contributed to our understanding of the extinction timeline. Some models suggest that while the initial effects of the impact were severe, the global climate might have begun to stabilize within a few decades. This could have allowed pockets of life to survive and slowly recover. It's also likely that the effects of the impact varied depending on location. Areas farther from the impact site, or in certain protected environments like deep caves or remote islands, might have experienced less severe conditions. But yet, some researchers go even further. There's a controversial hypothesis that suggests some non-avian dinosaurs might have survived for up to 1 million years after the impact. This idea stems from a discovery made in the San Juan Basin of New Mexico. Paleontologists found dinosaur fossils in rock layers dated to the Paleocene epoch, which began after the end Cretaceous extinction event. These fossils included remains of hadrosaurs and even a tyrannosaur, seemingly proving that some dinosaurs survived long after they were supposed to have gone extinct. Now, before you get too excited about the prospect of T-Rex living alongside our mammalian ancestors, it's important to note that this finding is highly controversial. Many scientists argue that these fossils were likely eroded from older rock layers and redeposited in younger sediments, creating a false impression of long-term survival. It's a reminder that in paleontology, as in many sciences, extraordinary claims require extraordinary evidence. But let's indulge in a bit of scientific speculation for a moment. If some dinosaurs did survive for thousands or even millions of years after the impact, what might their world have looked like? It's a fascinating thought experiment that pushes the boundaries of our understanding of prehistoric ecosystems. Imagine a world where the skies have finally cleared, but the landscape has been forever altered. The lush forests of the Cretaceous are gone, replaced by scrubby pioneer plants that thrive in disturbed environments. The air is cooler, the seasons more pronounced. In this new world, the surviving dinosaurs would have faced intense competition from mammals and other creatures that began to fill the ecological niches left vacant by the mass extinction. These relict dinosaurs would have had to adapt quickly to survive. Some researchers speculate that, in such an environment, these creatures might have become smaller over time due to the limitations of food resources. Imagine pony-sized T-Rexes or sheep-sized hadrosaurs roaming the early Paleocene landscapes. Of course, this is all speculation. The fossil record, as extensive as it is, still only provides us with snapshots of the past. The truth about how long dinosaurs survived after the asteroid impact likely lies somewhere between the extremes of they all died immediately and some lived on for 1 million years. What we can say with certainty is that the end Cretaceous extinction event was a turning point in Earth's history. It marked the end of the age of dinosaurs and paved the way for the rise of mammals, ultimately leading to the emergence of our own species. But it's important to remember that not all dinosaurs went extinct. The avian dinosaurs, the ancestors of modern birds, survived and went on to thrive, giving rise to the remarkable diversity of bird species we see today. As we continue to unearth new fossils and develop more advanced dating techniques, we may yet refine our understanding of the dinosaurs' last days. Each new discovery has the potential to rewrite our understanding of this pivotal moment in Earth's history. But the story doesn't end with the dinosaurs. The end Cretaceous extinction event affected countless other species as well. While the non-avian dinosaurs often steal the spotlight, it's worth considering the fates of other Mesozoic reptiles like the pterosaurs and marine reptiles. Pterosaurs, those magnificent flying reptiles that once ruled the skies alongside early birds, seem to have met their end around the same time as the non-avian dinosaurs. However, the exact timing of their extinction is still debated. Some researchers have suggested that pterosaur diversity was already declining before the asteroid impact. possibly due to competition with birds. The asteroid strike might have simply delivered the final blow to an already struggling group. The largest known pterosaurs, like Quetzalcoatlus, with its enormous 10-meter wingspan, would have been particularly vulnerable to the post-impact conditions. Their large size, which was an advantage in the stable late Cretaceous ecosystems, would have become a liability in a world where food was scarce and the climate was unpredictable. As for marine reptiles like mosasaurs and plesiosaurs, their fate seems to have been sealed by the end Cretaceous event as well. These apex predators of the Mesozoic seas vanished from the fossil record at the end of the Cretaceous. However, the oceans tell a slightly different story than the land when it comes to survival. While the land was experiencing rapid cooling due to the impact winter, the oceans, with their greater heat capacity, might have provided a slightly more stable environment in the immediate aftermath of the impact. This could explain why some marine life, like certain species of sharks and bony fish, managed to survive the extinction event. The extinction of marine reptiles left gaps in the ocean's ecosystems, which were eventually filled by other groups. Whales and dolphins, which are descendants of land-dwelling mammals that returned to the sea, eventually adapted to occupy many of the ecological niches once held by mosasaurs and plesiosaurs. One group that's particularly intriguing in this context is the ammonoids, those beautiful spiral-shelled relatives of modern squid and octopuses. Some researchers have proposed that certain ammonoid species might have survived for up to 1 million years after the end Cretaceous event. While this claim is still debated, it's gained more traction in the scientific community than similar claims about dinosaur survival. The potential long-term survival of ammonoids raises fascinating questions about the nature of mass extinctions and the resilience of life. It suggests that even in the face of global catastrophe, pockets of survivors might hang on for surprising lengths of time. This idea challenges our understanding of how ecosystems collapse and rebuild after major disturbances. Now, before the next extinction event unfolds, click on this video right here and uncover the most terrifying dinosaurs of the prehistoric world. See you there.